Today we will discuss Coulomb's law in electrostatics. Coulomb's law. So, in Coulomb's law we have 2 point charges. One is Q1 and the other is Q2. They are separated by stones R, and which we call a point charge. And what is the need of being a point charge? Point charges are those which have its size very small, so that the geometrical center of the body can be considered as the center of the charge. So this is the very small point charge. This is again point charge in a small body charged with Q1, and this is small body with charge with Q2. If the body is like this, so the charge is here and the center will be here. So the center of the charge and center of the mass of the body will be different. So the interpretations will become error with error. So we have to consider point charges. So according to Coulomb's law, it states that the force of interaction may be attraction, may be repulsion. So the force of interaction may be attractive as well as repulsive. And that we know, if the charges are like, then they will repel each other. If the charges are unlike, then there will be attractive force. So the force of interaction between the two charges will be directly proportional to the magnitude of the two charges. That means the magnitude of the force of interaction. So here it is not a vector, and inversely proportional to the square of the distance between them. If the charges are close to each other, then the force of interaction will be large. If the charges on the bodies will be more, then the force of interaction will be more. If the magnitude of charges is small, then the force will be also small. If the distance is large, they are large apart, then the force of interaction will be also small. So that means F equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, where this is also sometimes written as K Q1 Q2 upon R square, where this K equals to 1 upon 4 pi epsilon naught is proportionally constant, and here epsilon naught equals to 8.85 into 10 to the power minus 12. That will be Coulomb square per Newton meter square, is known as permittivity. Permittivity of free space means when the charges are placed in vacuum, then this force is to be applied. Even if they are placed in air, then we can consider this. But if these charges are placed in some medium, then that time the force of interaction will become less, and that will be equal to F medium will be equals to 1 upon 4 pi epsilon, that is the permittivity of that medium, Q1 Q2 upon R square. And we have the force in vacuum or free space, that is governed by F naught equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. They are placed at the same separation, but this in air or vacuum, and in this case they are placed in either water or some other medium. Then that time this F naught, F medium upon F naught will be equals to epsilon naught by epsilon. Rest of the things will get cancelled out, and this will come up and this will come this. So or you can say F vacuum upon F medium will be equal to epsilon by epsilon naught, that is equal to epsilon r, that is equal to small k. That is called relative permittivity. Permittivity of that medium. Of the medium means how much force will be applied in that particular medium, that will depend on the relative permittivity of that medium. Like case of water, this epsilon r, that means K, is 80. That means F in water is equals to F vacuum upon 80. Just from here, this is 80, so you can just see. You can just get it. F medium upon F naught is how much? 1 upon C epsilon r. That means 1 upon K. So this is 80. So F medium will be equals to F naught by 80. So this force will get reduced by 1 by 80th factor of the force in vacuum. If suppose the separation between the two charges is doubled, question, if R is 2R, then by what factor the force will get reduced? So here first we say F1 equals to K Q1 Q2 upon R square. Then F2 or F dash you can say will be K Q1 Q2. The charges are same, but the distance has become 2R. So square, so that will be K Q1 Q2 upon 4R square. That is nothing but F1 by 4. So 1/4, the force will become 1/4 of the first situation. Similarly, if the magnitude of each charge is doubled, question second is magnitude of each charge is doubled and separation is also doubled, then what change will take place? In the force of the Coulombian force. So, how to do it? So again, F equals to, that means first stage, K Q1 Q2 upon R square. Then F2 will be equals to K 2Q1 upon 2R square. So that means K Q1 Q2 into 4 upon 4R square, and 4 get cancelled, so it comes to the same as F1. So there will be no change in the force, magnitude of force. Now we will discuss vector form of Coulomb's law. अभी क्या है, force is a vector quantity, but so far we have discussed the magnitude of the force. Previously, what we studied, force, the magnitude of the force is directly proportional to the magnitude of the charges and inversely proportional to the square of the separation between them. So that time, this F was K Q1 Q2 upon R square, where the value of K was 1 upon 4 pi epsilon naught, and that value directly you can write 9 into 10 to the power 9. That is directly you can know 9 Newton meter square per coulomb square, and epsilon naught was 8.85 into 10 to the power minus 12 coulomb square upon Newton meter square. So after multiplication of this and dividing this, it comes to almost this, and the unit will be this much. So this was only the magnitude of the charge, but force is a vector quantity. If suppose we are interested in the exact force, that with the direction, then how we will get that? So let us discuss this here. Again, we will consider the 2 point charges. One is Q1 and the other is Q2, separated by some distance. And here we will have a frame of reference. The position vector of this will be R1 and this will be R2. Let us say this is R2 vector, this is R1 vector, and this is the origin. This is your x-axis, this is your y-axis, and here will be the z-axis. So, where will be the direction of the force between these two charges? That cannot be obtained unless you decide on which charge, force of which charge. That means if you decide force on one due to the second charge, that means force on the Q1 due to Q2 charge, then we will only be able to get the direction. So since though no sign is mentioned here, that means this is also positive and this also positive. So like charges repel each other. So if we put our pen over the Q1, then this Q2 is going to repel this charge Q1. So where is the pen? The pen has to move this way. So this will be the force 1, 2. The force on 1 due to 2, and this is now the vector because it is having direction also. So here it will be K Q1 Q2 upon magnitude K square, and still it is a scalar quantity. To make it a vector, we need to attach some unit vector, and that unit vector should be along this. So this is nothing but R21 vector. So you can apply here R21 vector unit, and here you can have R21 vector mod square. So this is K Q1 Q2 upon R square is complete, but after attaching a unit vector with this becomes the whole vector. And where is how you can express this R21 vector? That you have studied in 11th class, and that is tip minus tail. So according to triangle law of vector addition, this vector plus this vector is equal to this vector. That means R1 vector equals to R2 vector plus R21 vector. That means R21 vector will be equal to R1 vector minus R2 vector. That means tip minus tail. So tip of this vector is the R1 minus tail is the position vector R2. So R1 minus R2. So here we can have K Q1 Q2, and this unit vector along a given vector is always vector divided by its magnitude. And here already it is R21 square. So you will get K Q1 Q2 R21 vector complete divided by R21 vector mod cube. Where from this factor cube has arisen? It because of the unit vector has been converted into complete vector. पहले हमने पढ़ा था परफेक्ट में इनवर्सली स्क्वायर के प्रोपोर्शनल है, तो यहां पर तो क्यूब आ गया, ये बिकॉज ऑफ दिस. सो नाउ we can represent this force F12 equals to K Q1 Q2, and this R21 vector can be written as vector r1 minus vector r2 divided by vector r1 minus vector r2 mod q. So this will be the vector form of the Coulomb's law. Now, whatever the force on 2 due to 1, that will be, yes, again put the pen over the Q2 and see whether this Q1 is going to push it or pull it. So since it is positive, this is positive, then this Q1 is going to push it and the pen has to go this way. So this will be the force on 2 due to 1. So here we can again find force on 2 due to 1 will be K Q2 Q1 upon mod of the vector. Which vector? This time from it is 1 to 2. It is 1 to 2. So it is 1 to 2 mod. And here you have to apply unit vector, that is unit vector R12. Now in this case, where will be this vector? So this time this R1 plus R12, this time it has to be this one, R12. So here R1 plus R12 will equal to R2. So R12 will be equals to R2 minus R1. Tip minus tail again. This time the tip is R2 and tail is R1. So first I will convert it into complete vector. K Q2 Q1 R12 vector complete, and here will become R12 mod Q. Clear? Now this can be written as further K Q2 Q1 R12 can be written as tip minus tail. So R2 minus R1 upon R2 minus R1 mod Q. So this will be the final shape of the vector form of the force on the second charge due to the first charge. This is the force on the first charge due to the second charge.